I'm very happy to introduce the Advanced Computing and Electronics track, which is hosted today with the support of three major players. Intel Ignite, the AI and data-centric startup accelerator by Intel, Murata, a manufacturer of electronic components, and IMEC Expand, an R&D and innovation hub in nanoelectronics and digital technologies. Now, I'm very happy to introduce the first member of the jury. Martha Ivanovas leads Intel Ignite's European deal flow. With 15 years of experience in global data firms, she excelled in operational and business development for IT giants. Before Intel, she drove business development for Dell's EMA, HPC, and AI, managed sourcing for Dell Technologies Capital in Europe. She advises on tech geopolitics. She has a master's from St. Andrews and an MBA from Berkeley. She's also a retiring rugby player with 15 years of experience. So, Martha, join us, please.
Over 4,000 hours of running, passing, tackling, and that was just the training. One of my coaches, Xavier used to say, training needs to be hard. So for a normal match, the intensity is like here, then training needs to be here. Because if you train here and you get to here, you can manage it effectively. And when I got to Intel Ignite, I thought, Martha, this is the kind of environment that you're used to, the kind of intensity and performance. This is what we do at Intel Ignite. We train deep tech performance athletes. And we do this in three ways. The first one is speed of product market fit. One of our recent graduates said, we saved his company 1 year in development time by being part of the program. The second thing is access to funding. Our European portfolio of 60 companies raised $115 million last year. And our global portfolio has raised over $2 billion. The third thing is community. A community of over 2,000 Intel experts who come share their expertise, and a community of deep tech founders who are sharing best practices with each other. And we do this twice a year per location, 10 companies, 12 weeks. Product market fit, funding, community. So, if you're not training for the Olympics in Paris this summer, consider joining one of our global programs in Boston, Tel Aviv, London, or Munich. We're looking for the next generation of deep tech Olympians to join us. On vous attend.
I'm curious what Maxence is going to say after this. So yes, Olympians, unite. Now, Maxence co-participates in the deployment of Murata's innovation strategy in Europe. He is in charge of interactions with research institutes and innovation networks and acts as a link with the R&D teams in Japan. Maxence, s'il vous plaît.
Hi everyone. At a deep tech event like this, I'm guessing that many of you know Murata. However, for those who don't know us, Murata is a multinational based in Japan, leading in the field of the electronic components, at the cutting edge of the miniaturization and the innovation. Murata is strongly committed to the process of the open innovation with recognized research intelligence team based all around the world, EMEA, US, Asia. We have established numerous partnerships with research institutes and innovation networks. It's this commitment that brings us back to this year's global challenge. And we can't wait to see our finalist beats on that stage. Thank you.
Thank you. And the third Olympian in the jury, Bert Gisselings, is a venture capitalist specializing in hardware-based nanotechnology innovations, where IMEC technology, expertise, network, and infrastructure will play a differentiating role. Bert is dedicated to supporting visionary entrepreneurs, driving innovation at the intersection of technology and nanoscience, and is passionate about driving positive impact through innovation that shapes a brighter future.
Hi, good afternoon, everyone. I'm a partner at the Deep Tech Fund, IMEC Expand. So we invest in early stage, so that's C to A and B rounds. Deep Tech, MedTech opportunities where there's some solid disruptive potential with some semicon content in it. So the good news for you that in my previous life, I was a researcher and an IC designer, worked on photonics, and telecommunications designs. So hopefully we can have a good dialogue and see some nice technologies out there today. Thanks, and enjoy the show.
Thank you. And the fourth Olympian, I'm going to use that metaphor a lot today, is Cassiano de Boyo. She's a senior knowledge analyst at the Deep Tech mission of the Boston Consulting Group, the strategic partner of Hello Tomorrow. She drives the transformation of businesses towards a more sustainable, innovation-led future by implementing deep tech at scale. She can draw upon several experiences as at BCG in agriculture. She's also involved in the quantum ecosystem and leads the second quantum revolution topic at BCG, backed by a PhD in quantum physics from Université de Paris. Cassia? So I have a confession to make. The previous group, the energy section. Is there anyone in the room that was at the energy pitches before? Yeah. Yeah? Do you remember the energy in the room? Yeah. Do you think we can make it happen again? Yeah. Okay, 3 people. We can do this, right? Okay, so we have amazing startups that will pitch. They have 3 minutes to pitch, and you, the jury, have a total of 3 minutes to ask questions. We will start in the US with Jay. Just call him Jay, right? He's the CEO and founder of Align Carbon that enable the semiconductor industry to enter its new material age by unlocking the power of carbon nanotubes. Ladies and gentlemen, let's give it up for Jay.
Thank you. It's great to be here. I'm Jay Provine, CEO and founder of Align Carbon. We work on carbon nanotubes because of the needs in the computing industry. The computing industry has changed the way the world works more than anything else in the last century. Today, the planet is living off the power of computation. And we make over 10 to 24 transistors every year. That's an astronomical number. It's the size of the number of stars in the known universe. And we want to compute more than we ever have before. But at the same time, the efficiency gains that came from Moore's Law, where we shrank transistors and they simultaneously got more efficient and faster, are ending. And so because of this, we need a new paradigm to capture all of this great capability in computing that we want to achieve. Because if we don't, we're going to make enormous damage to the environment. Right? How do we get away from this trajectory we're on, where within the next 20 years, we'll be spending 1/4 of the world's energy on computation, equivalent to what we spend on transportation and housing? We need a way to go 1,000x better, or else we're going to pump millions or teratons of carbon dioxide into the atmosphere. Silicon has had its run. and it's driven all of this as the basic building block of transistors, but it's reached fundamental quantum mechanical limits that are really driving this energy bottleneck. So there needs to be a time for new world-changing material that can deliver on all the promises we want to have for computation going forward. So it's time to say hello to Align Carbon nanotubes. We're the first company to make carbon nanotubes in exactly the way they need to be made for circuitry and transistors. They're a perfectly aligned, semi-actively pure material delivered on substrates ready to go into foundries. The host of electrical properties of carbon nanotubes are what give them these unique properties that allow us to make more and better transistors than you can make with silicon. Enormous current carrying capacity, great mobility. And because of that, we can make carbon nanotube transistors that'll outperform silicon transistors at equivalent nodes by an order of magnitude. But that doesn't really get us to the kind of savings we need to have. And that's because planar FETs, planar transistors, are limited in that they talk to each other on the edge, and they live in the same plane. So only one-dimensional connections can be made. We need to get past that and move to the third dimension, which is unlocked by a unique property of carbon nanotubes. So they can be built at low temperatures, and now we can have monolithically integrated carbon nanotubes and transistors that can build in 3D. And this will get us that 1000x improvement and solve many of the environmental problems related for the industry. We do this by growing all our carbon nanotubes perfectly aligned. The core technology of our company is the ability to remove the unwanted carbon nanotubes, the ones that are not electrically desirable for making transistors. And we do all of this in a way that's manufacturable and can be scaled directly into the way computation and transistors are made today. So we've announced our Alcar platform. We can deliver wafers with perfectly aligned, high-purity semiconducting populations. We're looking for partners, people to build devices with these and with us to make the next generation of circuitry. So our team based in California, we're looking for the opportunity to work on this and bring material in the future. Thank you very much.
Thank you. Who would like to start? Yes, please.
AJ, wonderful talk, and always good to see some new technology coming out after silicon. So the good thing with silicon is you have an existing ecosystem, manufacturing platform. How do you see that come together for this new technology?
Yeah, so the key is we don't want to try to redo that, right? That's trillions of dollars of investment already there. So we can bring in a material that we don't have to change the way we do lithography, etch, deposition. And this has already shown a proof point where people have made a silicon and carbon nanotube co-fabrication line at the Skywater Foundry in Minnesota under a big DARPA program. So I think we've always thought of this as a way as how do we make this as seamless as possible, a new material that sits in an existing ecosystem.
You had it on the slide, but I think you didn't get to it. Talk a little bit about the traction and who you're working with, whether it's from a partner or from a customer perspective.
Yeah, we've sold material to TSMC where they're evaluating carbon nanotubes as a silicon, post-silicon material to look really specifically at making high-performance transistors at them kind of post-3 nanometer technology node. We're also negotiating with Intel, Global Foundries, and some other people to get larger projects in order now that we have the kind of consistent material that we can make and deliver to people.
Cassia?
Yeah, thank you. You build a network of CNTs and that are not perfect, and at the end of the journey, you get rid of the one that you don't want anymore. So is that correct?
That's right.
How do you deal with this variability?
Yeah, so we don't know where the unwanted, the carbon nanotubes that don't have a band gap are on the wafer, but we know that they interact with light differently than the metallic, or the semiconductor ones, the metallic ones interact with light differently. We use that to identify with a polymer pattern where they are on the wafer, and then we can etch them away. So it's kind of a self-defined etch mask based on the properties of the material itself, then we can remove them and have a pure population left to make devices with. Does that make sense?
Yeah, I just have a question about your fab objectives. So I didn't get the point. Are you going to stay a fabless factory and to propose just your design to CMOS foundries, or you're going to put your own manufacturers?
So we're material manufacturing. So we will develop the laboratories to make and manufacturing lines to make that material, and then we sell that material directly to foundries to use in process lines. It's introduced as a thin film material and can be processed through. We are excited to co-develop IP around device design with people, but mainly our focus is as a material supplier.
Short question at the end.
Are you raising money?
We are raising money. We have an extension to our seed round right now for $1 million. We'd love to talk to people about.
Just $1 million? Go.
Just $1 million. Well, more is always welcome.
Yeah, good. Any other question? Short, final? No? Thank you very much. Bye, Jay.
Thank you so much.
So if you have $1.5 million to spare, you come to me. Now, we go to Spain with Kilimanjaro Quantum Tech and Marta Estarillas. She's CEO, and what they do is that they build quantum application-specific solutions to bring quantum benefits today and maybe also tomorrow. So let's go to Marta.
I keep hearing that AI is the next big thing. But have you wondered where these models will run? Computers are reaching their limits. We cannot keep the same pace of development of the technology due to the end of Moore's law, meaning that we cannot keep enhancing the power of computers by chip miniaturization, and the only alternative is to make them bigger. But this has a cost in terms of size, price, and energy consumption. These machines consume the equivalent of 80,000 households in a year. And this not only affects AI, but also the development of pushing science forward in development of new drugs, new materials, new fields, and also solving very hard optimization problems present in the day-to-day of many industries, logistics, finance, energy, and so on. Fortunately, there's hope. And quantum computing comes as a new paradigm, a new accelerator of these computers with a complete new way of encoding information and manipulating it based on the laws of quantum mechanics. With this, we can design algorithms that can solve these problems in a faster, more accurate, and more sustainable way, actually 7 orders of magnitude of energy reduction. However, most of the available quantum computing solutions in the market are digital, and those are very much limited by errors, and those errors are not expected to be solved anytime soon, at least not in the next 15 years. This is why my team and I decided to embark in the journey of building something completely different. Full stack, analog, QASIC. Full stack and QASIC, because we believe that the road to bring quantum advantage to the industry in a shorter time frame to the market is by approximating as much as possible the design and the fabrication of the quantum chip with a specific use case. And analog, because this is a quantum computing paradigm that allows us to bypass errors and also simulate nature in a much more accurate way. Because as the father of quantum computing, Richard Feynman, said, nature is quantum. And if you want an accurate description of it, you better use a quantum computer. And to this, Kilimanjaro adds that in the same way that nature isn't classical, it's not digital either. It's analog. And with this vision, we are very proud of the achievements that we have achieved in the first phase of our journey. We have delivered the first quantum computer in Spain. We have delivered the first quantum computer in the Arab Emirates. We have built the first beta version of our product, a quantum as a service that allows users to remotely connect to our systems and run their solutions. And we have tested our product with clients in many sectors. And the future looks equally exciting as we are building the first quantum data center in Europe with widespread market solutions accelerated by our quantum as a service. And we have achieved an accumulated revenue so far of 10 million euros. But of course, our biggest asset is our team. And today, we are here to tell you that the next big thing is not AI. The next big thing is quantum computing.
Bravo. Tessia?
Hello. Do you focus on specific applications?
Yes, so this is our strategy to quantum advantage. Instead of focusing on universal general purpose systems, we think that now we need to tailor the design to specific applications in order to achieve to maximize the chances of get quantum advantage and enhance these probabilities. So we work very close with clients from different sectors, logistics, AI, chemistry, and finance, and energy, in order to understand very well what are the use cases and find tailored our designs for their solutions.
Gerd?
What would you say to investors that are kind of getting worried that this may take an awful lot of time before there's some real economic value generated?
Well, I think the type of investors that we are looking for are people that really understand how is the space. So it will take some time, but the impact that this might have is huge. And now is the right time to put this into the industry, to take this technology outside of the university, because we are in this inflection point that we are starting to have machines that can really provide value, and we need to connect it with the industry, with their pain points, with the different sectors in order to find the killer application.
Maxence, yeah.
So yeah, I have a question about the broad consumer computing landscape that's really large, and I would like to know how do you position yourself to compare with, for example, photonics-based computing or superconducting?
Yes. So we have two approaches. The first one is the architecture that we are developing. So we are based on superconducting qubits. So the chip that you have there is superconducting qubit based, but it's following flux qubits. Flux qubits have not been that much explored. Transmon qubits are what IBM, Google, and so on are doing. Those are for digital quantum computing. We do flux qubits. Why? Because they can be manipulated in an analog manner. And this means that they can map problems very well that are intrinsically continuous, mainly problems in nature and so on. Then the other type of differentiation is coherence. So we focus on quality and not so much on scalability, on scale of the chip at the moment. We think that now it's more important to pursue this vertical. And then also the type of interactions between the qubits. And also the approach, the strategy to quantum advantage is doing this quasic, even though in the long term, what we want to have is a fully programmable device. But in Spain, we say you don't start the house from the roof, you start from the base.
Martha, you have a question? Nobody else with a question? You have 2 seconds to decide. 3, 4, no? Good. Thank you very much. Gracias.
Thank you.
Very good. And don't forget to take your perhaps quantum chip. Now, very happy to introduce to you in the next minutes Rob Hendricks. He's CEO and co-founder of Phonontech from the Netherlands. They are reshaping 3D microelectronics with ultra-fast printing resolutions. Rob?
We all experienced how electronics became more and more powerful. And the reason is because we were able to make them smaller and smaller on a 2D level. But for the next generation electronics, we need to go into the third dimension. And when you stack chips on top of each other, you need to make three-dimensional interconnects. And that's still done one by one. So we developed the first ever scalable solution to print in parallel extremely fast. And it looks like this. So what you see here, you see lines flying up in the air, making a wraparound on a glass slide. And these are the fastest 3D interconnects in the world. And the technology is called impulse printing. And because we do everything in parallel, this machine, the first ever impulse printer, is 10,000 times faster. It's also an additive manufacturing technology, which means that there's a carbon footprint reduction of 1,000 times. And for the high-volume manufacturing industry, it's extremely important that we produce at the lowest cost. So we believe that all the next-gen electronics are enabled by impulse printing. And this is also what we see from the industry. So we had a lot of traction from the semiconductor and the display industry. So we did dozens of introductions. Then we gave free samples to showcase that we can print any type of material. And we already ran 4 R&D projects, and we expect before the end of the year to already sell 2 printers. And this is the team. So the guy in the blue is the other co-founder of Phonontech. That's Fabian Brüning. And you see here a team of 9 people. We founded a year ago, and they are standing in front of the machine, which they built in less than a year. So it's a very high-skilled team, and we will change how electronics are being manufactured. What we also built is this very small box. So this is a printer in a box. So whoever didn't press the button yet, please come to our booth and press the button.
I really thought you were going to open that. and blow us away. But I think he kind of did. So let's go to Cassia, please.
Okay. It looks like a really final product. So do you have a commercial perspective right now?
Yes, so we have two versions of the printing technology. One is the flat technology, where we can actually use stencil and screen printing to go to resolutions of around 30 microns. There's a lot of opportunities there, but the real potential is when we go to sub 10 micron features. And then when we show this, that's really exponential. There are really, the high volume manufacturers are basically saying, if you show this, we will we get purchase orders right away.
Thank you. Bert, or?
Yeah, so for all of, indeed, like Rob said, if you have not tried opening that box and pushing the button, you should definitely give that a try, because it is as fast as you saw on the move. So I tried it, it's pretty amazing. So great talk, Rob. I was wondering, so can you extrapolate a little bit from where you see this, what you have today, to where this technology could eventually go?
Well, what you see, indeed, what I said, so everything became smaller in the 2D, right? So everything was dominated on the front-end semiconductors, but they're running out of space to go smaller. So you have to go into the third dimension. So it's shifting from the front-end to the back-end semiconductor. How do you package all these electronics in a smaller space? And this is really the solution to connect all these chips at high volume.
Thank you. Marta? Yeah.
Yeah, talk a little bit about the use cases for this. I mean, the industry, who are your customers going to be, what this is going to be used for?
Yeah, so one of the first ones is printing pillar structures for HBM, so memory. They need to stack a lot of chips on top of each other. They now use lithography in combination with electroplate print to make all these pillars, but they can only do it on 2D, and they need to go in 3D. So they really like this technology. The other thing is for micro LED assembly. So if you have a TV, big screen, you have 33 million interconnects on a panel, and we can print these very small at super high speeds. The other thing for display is, for example, the big screen. It's all made out of tiles, and they need a wraparound electrode to make a connection from the front side to the back side. So the front side, that's where you have the pixels. The back side is where the driver is. So you need a wraparound electrode, because that's the cheapest way to do it. They've proven it with the nozzle one by one, but they said we're going to never industrialize that. So they really think this is the solution. And if you want to see the wraparound electrode, it's actually in this box.
Okay, really fast.
Just a short question about the IP portfolio. How strong is your IP portfolio around the impulse printing and its related components?
So we filed 14 patents, and there are 2 more on the way.
Okay, good, great. Thank you very much. Bye. Let's go to Austria now with Vitrea Lab. Chiara Greganti, CTO and co-founder. What they do is that they deploy the brightest and most energy-efficient laser-based displays for augmented reality and VR. Chiara?
Hi, this is Chiara, co-founder of Vitrea Lab, a photonics startup unlocking augmented reality for everyday use. Augmented reality has the potential to reshape how we communicate, we interact with information, and we perform our daily tasks. But why we still don't have such smart glasses? Well, we need bright displays. All competitive technologies out there, developed by startups, but even tech giants since many years, still struggle to create visible images in an outdoor environment. We in Vitrea Lab have powerful technology to finally bring augmented reality glasses for outdoor use to everybody. We produce the display that projects the images into the AR glasses. This system is based on standard systems, except the illumination part. This is our core innovation. what we call quantum light chip. It's the only photonics chip in the world that can produce a laser grid illumination. With this, we can create not only the brightest images, but also with the highest efficiency, the best image quality, and all packaged in a small form factor. The augmented reality display market is emerging now, is expected to hit more than $10 billion in value in 2030. And while competitive technologies have limits, the market demand is pressing, Vitrolab has a unique opportunity. Today, more than 20 companies are waiting for our new demo, the brightest AR display in the industry, to test it next month at their facility. We plan to enter the market with the first enterprise product with customers like Digilens, who have already their own headset in the market, but they are still desperately looking for alternative displays. The small sales volume of the enterprise sector is the perfect fit for us to grow our production capabilities and scale up very, very fast in only 2 years to reach the large volume of consumer markets, serving customers because Apple, Meta, and so on. Our advantage is our proprietary fabrication process and product design. Behind all this, we have a top-level team, including a business developer with expertise in corporate sales, and world expert engineers in photonics manufacturing and AR design, all working in our state-of-the-art facility in Vienna. We have further support from advisors coming directly from the industry and investors in the deep tech area.
So Maxence, already with a question. Let's go.
So you're talking about the big players. So did you have any partnership with them already?
No, they are all waiting and eager to test our demo. So we will visit them with a private tour in US in April and May, and with them, with that we can start our collaborations.
Martha? Bert? Yeah.
How will you scale out from your lab in Vienna to a commercial foundry setting?
So what we produce in our lab, it's only these photonics chips. The photonics chip we have, it's not based on semiconductor facility. It's a completely new process based on direct laser writing. That means the capex is very low. We have just opened a second facility in January to really develop the pilot line for production for the low volume case of the enterprise sector. And going to a large volume for the production of all the photonics chip, it's really easy. It's replicating and scaling up these machines. And we don't need many of those to reach millions of units.
Okay, Martha has a similar question, I think. Okay.
Are you raising any money?
Yes, we are raising around after the summer to be closed at the end of the year, really after we get the first really push from the customers in May, June when we show the demo.
Would you mind sharing a number?
Yeah, we are raising between 5 and 10 millions.
12.
12, yes, we offer more.
Okay, any other questions, Bert?
If I may, so there's a big debate on whether you want to do kind of projection, like I guess you're suggesting, versus a micro LED approach.
Mm-hmm.
What's your take on that?
Well, micro LED is under development since more than a decade at companies like Apple and others, and also then at startups like Genomic LED and so. We believe the tech might be potentially powerful in the future, but still has a very long way to go. And still, our brightness is still, it's unbeatable also with the micro LEDs, because laser light can really be shaped as you really want against incoherent light, so LED light which goes everywhere.
Great. Any other questions? No? Super. Very concise, very clear. Thank you.
Yeah.
Have a great day. Bye.
Thank you. Bye.
I think Chiara had a fan in the audience. Okay. 2. Okay, yeah. Sorry. The other one was very silent. So from Vitrea Labs to Literal Labs. Literal Labs in the UK with Noel Hurley. He's the CEO of an energy-efficient semiconductor architecture enabling truly powerful and explainable intelligence on any device. Noel?
Ladies and gentlemen, I'd like to say it's a pleasure to be here and just say if we're going to tackle the energy challenges that we have today around AI, we can't afford to tweak around the edges. We need to take a fundamental look at the computational complexity of the AI technologies that we have today, and that is what we are doing at Literal Labs. At Literal Labs, we're making a new generation of AI technology that is based on a combination of propositional logic, if-then statements, and something called a settling machine. The research and the results that we're seeing from this technique is showing orders of magnitude speed up in terms of AI performance. It's showing massive reductions in energy, and also because we've reduced the compute complexity of AI, in-field tuning and training of models becomes possible. This technology is based on logic and therefore is naturally lends itself well to explainability. The technology is 5 years in the making. It was a collaboration between Newcastle University and the Centre for AI Research in Norway. And we are the first company to be spun out of using this new technique. We are looking at developing a product to address the issues that we currently see in the edge AI market. We're out raising £2.5 million right now to build a tool chain that will allow customers to take their data sets and train models using this technique, and then able to deploy those models into those edge AI devices. When I talk about team, that's how we're spending what we're raising our money for. In terms of team, myself, I am 20 years at ARM. I used to be the VP and General Manager of the microprocessor team at ARM. I have alongside me Professor Alex Yakovlev, over 1,000 published papers, research papers in semiconductors and computer science. Professor Rishad Shafiq, and also Professor Ole Christopher Granmauer. These are the godfathers of this technology. They've been developing it for the last 5 years. And alongside, I also have Jem Davis, an old colleague of mine that used to run machine learning at ARM, and Xavier. And alongside all of those, 3 PhDs and 3 full-time engineers. Thank you.
Thank you, Noel. Yeah, please.
Do you or can you have intellectual property on this?
Yes, we can. So we currently have 2 patents. Those patents are based around, when I say propositional logic, we have clauses, how you organize those clauses, and also when they are deployed in silicon, how you handle, compress that data and handle that data. So there's 2 patents that we have today. And then, of course, we're building up know-how in terms of architecture. And over time, we'll be looking to then further patent as we move forward.
Martha, yes, please.
Noel, how could this fail?
Oh, that's a very good question. So I think with many of these technologies, community is going to be important. What we're going to have to do is really enthuse engineers to adopt this technology. That's one of the challenges. Whenever you've got a new piece of technology, how do you get it adopted? Actually, at this event, I've been really encouraged because I've had a whole bunch of PhD students coming around, been working on AI, fascinated by this topic. And so our plan is partly we're doing a lot of open source work. We're building a community around settling machines as part of our strategy moving forward.
And how does one program a settling machine?
So the methodology that we use is the same that any data scientist, AI engineer would expect. You take a data set and you train a model. So the models we produce are C++, they're wrapped in Python, they're very familiar with the engineers. One test that we did do when I didn't mention up here, I've got a new CTO joining in May, and as part of that process, we had a challenge for them to program a settling machine. Out of the 6 candidates, 5 of them managed to program a settling machine over the weekend. So they picked it up from scratch. That was really encouraging, that people can actually apply current AI thinking and processes to this new technology.
Could a machine also do that? Can you recompile an existing code and map it on your machine?
My CTO we're having exactly that conversation with him. Yes.
So how do you define your specific target market? Because it could be very competitive, I guess.
Yeah, and in terms of selection of target markets, what I've chosen in the edge marketplace, this is one of the most constrained markets in terms of there's not a lot of compute performance there. They have energy constraints and also cost constraints, frankly. So we're a hyper-efficient technology. That is where we will find our best competitive advantage. Fundamentally, if they're using a neural network in that space, I'm confident that a logic-based approach will win out.
Great. Thank you, Noel. That's
Thank you very much.
From the UK across the sea to Denmark with Sanofi, Hitesh Kumar Sahu, he's CEO and co-founder of this company that builds sustainable optical interconnect solutions for data centers and high-performance computers. Hitesh?
Hi, I'm Hitesh from Fanify. Yes. Can I start?
Give it 10 seconds.
Okay. I have some time. That is started.
It's gonna be okay. So tell us a bit about yourself.
Yeah, so I'm from India originally. I moved. Okay, yeah, there it is. Fast internet. Now you know the use case. Hi, and today we are going to talk about data centers. It's the place where all of our information is stored, analyzed, and processed. These are massive infrastructure and consume a lot of energy. These are now estimated to consume 21% of the global electricity. That is quite a big number. And if you go inside data center, you'll find big rooms filled with servers and switches, and they're all connected to each other using these, which are called interconnects. Now, interestingly, these interconnects take up 27% of the data center electricity. At Fanify, we can make them more power efficient. To understand how let's look at how it's done right now. They take a laser to modulate zeros and ones onto light, switching it on and off, which is very simple. But fundamentally, light is an electromagnetic wave, which is very much like a highway with 3 lanes where you can send data. Unfortunately, due to cost and complexity, we can been using only 1 lane. At Fanify, using our photonics technology, we can remove that roadblock and enable traffic on all the 3. By doing so, we can enable 4 times the data that was possible per laser. And doing so, we bring a much efficient interconnect platform. For the end user or data center, it means 10% in power savings, which directly translates to lowering their carbon footprint and millions in operational expenses. These numbers are just for 1 data center. And the data centers are constantly growing because there's a need for them, and they are expected to grow at 11% annually. We operate as a scalable, fabless design approach, which means we focus on the design. We partner with a manufacturing hub to make the chip, which is our product, which you have. And then that is sold to the OEM, who then takes it, puts it together into the transceiver or interconnect, and sells it to the end user, which is the data center. For them, it's a plug-and-play solution. And there are many partners. We have these partners, some of the key partnerships in place. The market is a strong multi-billion-dollar market, reaching $26 billion in 2030. Interesting place to be in. To do this, we are a strong and diverse team. I am leading the business front. I have a PhD in photonics, and I have background in business development and fundraising. My co-founder, CTO, he is having a PhD in photonics and optical communication. Besides, we have an amazing team to help us in our journey towards bringing this technology to the real world and make a real impact. To sum up, we have a key to the greener, faster tomorrow, and we are raising pre-seeds. So come talk to us. Thank you so much.
Very good. Martha?
So Hitesh, you're on this journey to build your technology into product. Maybe talk a little bit about how you're thinking about that and where you want to end up, because there are different companies focusing on different parts of the photonics compute landscape, right? Is it a component? Where do you want to end up?
So our technology is actually a disruption in the architecture on how you encode electronics into optics. So essentially, it's this photonic chip which is the solution for us. So we are making the conversion of electronic zeros and ones into photonics efficient by accessing all the three domains. And that solution is in the photonic engine that we will sell to the OEMs.
In terms of development, where do you stand?
Thanks for asking that question. So over the last 3 years, we have actually taken the design from a simulation to a prototype stage. We have shown it to the industry, demoed it to the industry, and got a really positive feedback. It has also helped us create some partnerships with the industry for our next product development. It has accelerated our product development by more than a year now.
So to continue with this kind of question, so what is your expected timeline for bringing your technology on the market? Because it's a very competitive market, but demanding technologies for sure. So what is the timeline?
It is a very competitive technology, a competitive market. So what we have done is gone out and talked to the end users and consumers, and we have our first MVP going into to the industry in 1.5 years from now, and that will be done with an industry partner, so that we want to work with them for a product which they will like. And at that point, we'll be ready to do field trials. And yes.
Do you happen to need any money?
Sorry?
Do you happen to need any funding?
Definitely, always. We are raising our pre-seed round. We estimate close to 1 million in the pre-seed round. And definitely there's more to ask. We want to, this pre-seed round is aimed at a demonstration with the industry, and we want to generate a proof point with the industry before we actually scale our production. So we are going lean, and we're working close to the industry to actually create a product that they want to deploy.
I think in this industry, this sounds like a bargain. 1 million for what you guys are doing, which is really fantastic. But after that, how do you scale it up? How much more will you need to really get it into these Google data centers?
Yes, we will need close to we estimate close to 5 to 10 million in the seed round, and that we want to aim it after our demonstration with the industry, because we know it would bring credibility and confidence to the investor that we have done something and there's a customer on board on our journey.
Lovely. Thank you very much.
Thank you.
Bye. I'm pretty sure he said 2 million. Right. So again, you can come to me for that. Now, the last pitch of the session, QPT from the United Kingdom with James Cannings. He's chairman of this company, Next Generation Power Electronics for High Power Electric Motors. James?
Hello, everybody. Yeah, I'm James, and I'm going to talk to you a little bit about, as Compound Semiconductor very kindly put it, how we're saving the planet with GaN, or gallium transistors. So Electric motors consume a huge amount of the world's energy, and the speed of an electric motor is controlled by a device called a variable frequency drive. Inside that, there's a load of transistors, and the faster the transistors can switch, the more efficient the drive can be, and the smaller and the lighter it can be. But the industry's stuck today. These are all universally used, either silicon transistors or silicon carbide transistors. But the world has a much, much faster transistor, the GaN transistor. What QP2 do is switch GaN transistors at very high power, faster than they've ever been switched before at high power, and then encapsulate into a module that you can see on screen all of the very complicated thermal and electromagnetic issues that come with operating at these very, very high frequencies. This on screen, these are our modules, but this is a reference design for the world's first high-frequency GaN-based variable frequency drive. This is a 10 horsepower unit, which is about 100 times smaller than the commercial units sold today. It's around about 10 times more efficient. And very importantly, it significantly reduces overall system costs to the electric motor companies and drive companies. Market's huge. It's industrial robotics, it's heat pumps, it's air conditioning, it's any three-phase motor, and of course it's electric vehicles of any type, somewhere north of 50 billion. We're currently building the world's first drive for ABB, as I say, a 10 horsepower drive. For them, we'll be testing that with them in their labs in the US later in the year. Since the news broke earlier this year that ABB were leapfrogging silicon carbide to develop the world's first high-frequency GaN-based motor drive, we were approached very rapidly by Infineon Automotive, Nidec, the Japanese motor company, Siemens, Danfoss, and a number of others, very, very interested in this kind of breakthrough tech to get them over the plateau. It's a battle-hardened team. I'm very proud of this bunch. Rupert Baines, ex-CEO of Ultrasoc, acquired by Siemens. We have both co-founders of GaN Systems, who were acquired by Infineon for $830 million last year, one of whom sits on the board. And these guys really deeply understand how difficult it is to go from stuff in a lab all the way up to scaled volume production. And it's a combination of manufacturing and licensing, and take questions on that if you like. I'm very passionate about the business because the environmental impact prize of converting the world onto GaN-based motor drives and getting over this barrier is in the order of magnitude of removing all of the planes from the sky. So we really want to get this technology out there. Thank you for listening. That was terrifying.
This is the first startup that admits on stage how it feels.
I thought they switched the mic off. That was
No. So let's go to the jury. We have 3 minutes. Who wants to start? Gert?
Could you comment about the business model? What are you actually selling?
Yeah, so the product is essentially I would call it the ultimate transistor switching module that can be then used by companies like ABB or Siemens or anyone else like Danfoss who create these variable frequency drives for them to be able to build. It's a power module like they would buy a silicon carbide module or an IGBT module to create these variable frequency drives. And the model is we will have some scale production, a few 100,000 units, but it's really more likely to be outsourced production and licensing to companies like Danfoss or Infineon. But it's a power module for a vehicle.
And is the GaN your own, or you get the GaN from
No,
some
we're not a
factory?
GaN transistor company, absolutely. Any GaN company, if you're aware of them, like GaN Systems or an Navitas in the US, Cambridge GaN Devices, we'd consider them a partner. We're an enabling technology that unlocks GaN into these high-power markets. It's the darling of the low-power world at the moment. So it's a 650-volt GaN transistor from GaN Systems that we use today. It's the only one that will switch at 1 nanosecond.
Martha, yes?
James, what does it mean that you're chairman? What's your relationship with the CEO, and what are your roles?
It means I know enough to be dangerous, and if people ask me really difficult questions, I can go, but I'm just the chairman, I'm not the CEO. I was actually the angel investor, met Rob, our amazing scientist, 6 years ago, became an advisor, came to understand the business more, loved it, became chairman, stuck my nose in more and became executive chairman. So really my role is representing the business. I do a lot of the fundraising because actually I'm not from the tech world, but it's a useful skill to be able to convert that over. And I'm not needed in a lab. I can't help with any of that. So it's kind of a useful asset. I'm sure you can appreciate it's such a drag on the time of the founders otherwise.
Anybody? Maxence, Cassia?
So yeah, about the integration, how easily can your GaN modules be integrated into the existing power electronics design for electronic motors that they used to use SiCaps or silicon?
Yeah, it's why we've created a module and haven't become a sort of fabless semiconductor business. We could and can sell the ASICs, the chips, but we'd have to then sell that with the reference design because it's not a power electronics challenge. It's an RF microwave engineering issue, and that's the problem. So the modules are drop-in modules.
So you mean like it's plug and play, like something like that?
Yeah, you'd have to follow ABB would have to kind of follow the reference design and, plug that in and use our output filter, but it's really easy to do, as easy as it can be, yeah.
What are your main limitations?
We need 1200 volt GaN transistors to go up into the EV market, but we've got a big place to play in for right now, HVAC industrial, but we need high power.
challenge. Cheers.
Almost did that in like 3 seconds.